My hanging mass, or hanging weight, is the hanging mass times acceleration due to gravity, minus my friction, which is mu sub k, because it is sliding, times the normal force up there, which is the track mass times g, is equal to my total mass, mt plus mh, times a. Okay, dramatic pause here for people to catch up in writing and ask questions. I know that for some of you, this looks like a little bit of alphabet soup.
Is that second mass on the left, in between the G and the mu, is that supposed to be a capital T? Or
Yes, that's a capital T there for a track.
And then the friction above on the first line?
That's supposed to be the same T.
Okay.
Other questions? Now, in the lab, I go through and actually solve for mu sub k, but let's plug in numbers now. We can't get rid of the g as nicely as we could before, so that part matters. The mass hanging was 300 grams, or 0.3 kilograms, times acceleration due to gravity, since this was a specific lab, 9.798 meters per second squared. Let's see if I can go to that. Minus mu sub k, which is what we're trying to find, times m sub t, the mass on the cart. Oh, it popped off of that. So that's a 500. We'll just trust it. Actually, we probably could do both of it. That's not that much. All right, apparently we have to do the cards separate. Well, my estimate of 60 grams was way off. All right, that's about 203 grams. So this would be 703 there, and 703 there, which means that's going to be smaller. All right, so the mass on top was a 500 gram mass in something that had 203 grams, so 0.703 kilograms times 9.798 meters per second squared equals my total mass, which is 1.003 kilograms, times my acceleration, 1.15594 meters per second squared. I'm going to be shocked if this actually comes out less than mu mass, but who knows? Take mine. So the math part is ignore the units. So 0.3 times this. So now we need some help. $2.9394 minus, and then this.
$6.88.
there is a mistake on the board here. Correct that in just a moment. This.
$7.1774.
7.1774. All right.
I think that's right.
No, what I claimed earlier was a mistake, was not. Let's just see if I made another careless error. So the box by itself was 203, plus I had a 500 gram mass.
I think my number was wrong.
Yeah, the 7.
Yeah, that was completely
The
wrong.
7 should be 1.159.
Oh, 1.159?
1.1594.
Okay. There, okay. We'll get a positive answer this time. All right, so I'm solving for mu, this mu sub k right here. So I need to start getting rid of all the other stuff, since that's my unknown. Well, so you start on the outside and you work your way in, sort of reverse of order of operations. So first let's get rid of this. So let's subtract 2.9394 from both sides, minus 2.9394. And we end up with, so on the left-hand side we'll have negative 6.888 mu sub k is equal to negative 1.78. Now we have to get rid of this right here, because again we want UK all by itself, so now we have to undo the multiplication with division. 6.88 divided by negative 6.888. And we end up with a mu sub k equal to dramatic pause for someone to volunteer. 0.25-ish. 0.26. Units?
No units.
Say it again?
No unit?
Correct. It's just, if this is a coefficient, this is not force itself, it's just related to the force. It has no units whatsoever. Now it is less than the value we had before when we had a mistake in it. I think if we actually redid that one over there, we would end up with something less than 0.26, and yeah, it's disappointing for me. A little soon for you, because you're expecting nothing but perfection. Which is why I really look forward to grading your labs, because I will have tears of joy streaming down my face from the perfection.
What number are you talking about?
All right, so that's the number we got from mu sub k, and over here, mu sub s. We did 560 because I did a really bad estimate for that mass, but it should be 170 over 703.24, which gives some credence to the idea that, are they really two different numbers? Then you get into the idea of error bars, which is beyond the scope of this class, but science never gives straight up numbers. It's always plus or minus something. All right. Questions? All right, the last topic of the first part of the course. we've actually been practicing for a while. It's this idea that forces come in pairs. So let me sort of write it out more formally than the classic expression of it. For any force A exerts on B, A meters objects, B will exert the same type of force on A with the same magnitude of the force A exerts on B, but in the opposite direction. The more common expression of this is for every action there's an equal and opposite reaction, which I really don't care for, but it's definitely much more succinct.
You answered my question. I was going to ask if that was like the conceptualization of like for every action there's an equal and opposite reaction.
Yeah, the trouble I have with that expression, or I guess if you watched that video already?
Yeah.
Okay, so my reservations are in there.
Yeah.
Let's make sure I didn't leave any words out. For any force A exerts on B, B will exert the same type of force on A with the same magnitude of force, but the same magnitude of force A exerts on B, but in the opposite direction. Yeah. So that's why when we do our force diagrams, they come in pairs. The pairs point in opposite directions. And we use the same label for them. So the ground is pulling, the earth is pulling down on me with about 225 pounds of force. I am pulling up on the earth with about 225 pounds of force. So earth pulls down on me, I pull up on the earth. All right. Let's put that in a slightly different context. If Bob pushes on a box to the right with 15 newtons of normal force, or not if, just Bob pushes on a box to the right with 15 newtons of normal force. I don't know why I capitalized normal, but I did. All right, just a simple statement, a picture of a box, Bob's pushing on it. Whenever you're given this, you can always find the reaction force best by first identifying what are the two nouns, or what are the two objects involved here. What are the two objects?
Bob and box.
Yeah. So I've got Bob and box. What is the direction of the force?
To the right.
And so in order to write the reaction to this is you just flip the nouns and switch the direction. So box pushes, I guess a box, pushes on Bob. If you wrote a Bob, I would understand. Pushes on Bob to the left with 50 newtons of normal force. Only things that have changed between the two are I switched the two objects and I switched the direction. I think there's a master set problem, chapter 4 or 5, which when I do this.
So even if he's moving the box is still pushing on him?
Yes. Yeah. If the box is moving, he might not be pushing as hard as he did before, but he's still pushing on it, and the box pushes back. And the way that Bob can tell, unless of course he has nerve damage, is that he can feel the box, because the box is pushing on his fingers. But since I made up Bob does not have nerve damage.
So we don't know if the box is moving.
We do not. Whether the box moves or not is completely irrelevant to this. Because to know if the box moves or not, we would first have to know, was the box moving to start with, and also what are the other forces acting on the box. All right. With that, I say I'm done with 4 and 5. This is technically is 5, and the other stuff I was doing was 4. Today is the 31st. Let's see, master set 3 is due then. I don't want to push the test out too far. All right, so the 9th would be a Friday. Let's see if I can get a better marker. So Monday, master set 3 is due. Master set 4, 5, it's one object. We'll say is due Friday of next week. And then the first test on Valentine's Day?
Sure.
All right, sounded like enthusiasm.
Wait, Valentine's Day is not next week, but the week after.
Correct.
Okay.
Test would be 2 weeks from today. We will cover other material before then, but just I want to give you time to study and absorb. Look at the old tests that are posted. Now, the way I write my tests is I have all the other tests in a folder, in various folders. The essence of it is I bring up that page, I close my eyes, I move the cursor up and down, and then I click somewhere. After about the 3rd time I actually click on something other than empty space, I click on a folder, and that's my starting point. I will take that test from whatever semester that was. I highlight the whole thing in yellow. Once I have the whole thing in yellow, I then start going through problem by problem, going, oh, I don't like that problem, I'm just going to change the number. Ooh, that was a horrible problem, I'm throwing that one out. Ooh, I got a variation of this problem, let me do it this way. I watched something on TV last night which inspired me. Let me throw in, and that's slowly how the test morphs. But I have a bunch of old tests that are posted, some of which have answers, some of which do not. But in preparation for the test, I do recommend you at least take a run through one of those tests, as well as watch the videos, do the homework, do the master sets. Master set problems for up through 4 and 5 are all old test problems. Questions? Then let's mosey on down to the lab room and figure out if you can get better results taking more time and care than I did to figure out the coefficients of friction. Instead of recording just an empty room.